AC motor soft starters. In this presentation, we're going to be looking at how AC motor starting is controlled, soft starter operation, common connections, and a few summary points. AC motor acceleration can be controlled in two ways: mechanically with resistors, reactors, auto transformers, or even Y delta setups, or electronically. Mechanical acceleration control means that we're controlling the acceleration of the motor to reduce the starting torque by lowering the voltage across the motor windings. Now we have all sorts of different types. Part winding, Y delta, the lower voltage at start equals a lower current, and that lower starting torque to prevent drive belt slippage and jarring in mechanical loads. Even with the auto transformer, the methods are considered bumpy. Even when closed transition systems are employed, it's never really a smooth acceleration. And so, although it's accomplishing the intended outcome, which is reduce the torque at start, it's not really the most elegant solution. And as we know, some of these mechanical reduced voltage starters need to have special motors in order to operate correctly. They can also be intensely inefficient due to the heat generated during the starting sequence, such as in this primary resistor reduced voltage starter. An electronic soft starter reducing voltage with contacts. Reducing voltage with contacts and the generation of heat is an inefficient method of controlling AC motor acceleration. And since the end effect desired is a reduced line voltage to the motor, using inverse parallel connected SCRs or triacs can be used to adjust each phase at the same time. And so an electronic soft starter is often an item that would simply replace the standard full voltage motor starter. You would need to supply your own start stop push button assembly typically, and it would wire into the electronic board. An AC soft starter will provide acceleration control presets, deceleration control presets, overload protection, and the ability to connect into a larger digital control system, such as a PLC. Notice it does not provide reversing control. It does not provide running speed control. It is only there to provide acceleration and deceleration and overload protection. In this way, a standard motor starter can be replaced by a soft starter to provide a more gradual and smooth increase in speed and deceleration. If we look at the size, although this may not be to scale, this does give you an idea as to the difference of size for different types of applications. A soft starter, being all electronic based and no additional external components, really takes up a significantly less smaller footprint than a comparable auto transformer reduced voltage starter. Soft starters use triacs or inverse parallel connected SCRs to control the power circuit of a motor when it's first started or when we are stopping it and decelerating. The electronics are bypassed after acceleration and before deceleration. Let's take a look at how that works. Inside the soft starter, we have an arrangement of three independent inverse parallel SCR circuit connections. And we also have a bypass contact, which you can see that's located in parallel with each set. When we first energize the motor, the SCRs are gated late. And what that means is that the sine wave that is sent out on A, B, and C is going to be fairly low power. As the motor gains speed, we gate the SCRs earlier and earlier to allow for a higher degree of power and thus a higher voltage going to the motor. Finally, we get to a point where we're all the way back gated at almost 1 degree. And when we do that, or near the beginning of both the positive and the negative alternation, when we're there, it means that the motor has reached full speed now and we're ready to transition. Now, the soft starter is not intended to operate with the triac or with the SCRs continually while it's running. The amount of time that we have just looked at for this 4 transition steps of gate trigger is going to be in the matter of seconds. At this point, the system will automatically close the bypass contacts and in this way shunt out the SCRs. This means now the motor is running on the full line voltage from the AC source and has effectively bypassed any of the electronics inside. The bypass can be built into the soft starter, which is most common, but it could also be an external contactor for extremely large motors. So as we've just seen, there's the internal bypass, and on a much larger soft starter, an external bypass. Now, the soft starter has acceleration and deceleration presets, which are typically values that most installations will be able to use at least one of. They're pre-programmed into the soft starter, and the preset which best suits the intended operation is then selected by the installer. Here are some of those different presets. They will have specific ramp up times, perhaps even a current limit, kickstart. So maybe depending on the mechanical load, we want a slightly higher voltage to just get the shaft turning, and then we're going to ramp it back down. We also have coasting to rest, coasting to stop. We have just general time or current limiting and pump controls for starting and stopping of pumps, which have very specific types of inertial and torque requirements. We have different types of, well, this one's linear, speed, accel, and deceleration, torque control. There's all sorts of different settings. You don't need to memorize these, and neither do you need to have full notes on each one. Instead, all we need to know is that if we purchase a soft starter, there are a number of different presets that we could use for our installation, each one having different benefits and negatives that we would read in the manual to determine which one is best for our application. We can even at times utilize soft starters to run resistive loads. And in a three-phase application, depending on what the phase angle is, we could utilize this to ramp up or ramp down the heater. So soft starters can reduce the voltage at start and stop only. They reduce the starting torque and the inrush current. They do not change the frequency to the motor. If it's a 60 Hz motor, it continues to be 60 Hz being applied. Soft starters provide a phase angle shifted sine wave on all three phases. They will not control running speed of the motor. They provide overload protection, and they typically require an additional start-stop push button station in order to operate, much the same as a standard full voltage starter.